Okay, this is going to be lesson 10.3, and we're going to be looking at the quotient of powers properties. The key idea here is that when you divide powers with the same base, you will simply subtract their exponents. So similar to what we did when we were multiplying them, right? We were adding the exponents. Now we're subtracting them, and I'll kind of show you why. If we have 5 factors of 4 in the numerator, and we divide by 2 factors of 4 in the denominator, you're kind of used to the fact that you know that 4 over 4 is equal to 1, so you can kind of cross-cancel these. What are you left with? 3 factors of 4. So instead of going to the trouble of doing all of this work and writing the repeated multiplication, mathematically speaking, you know that if you are dividing, right, and you have powers, they have the same base, that the numerator exponent minus the denominator exponent would give you the number of factors remaining. So we'll give this a try. Okay, here's example 1. Notice in A, the base is 2, and the numerator has an exponent of 6, denominator has an exponent of 4. So using the power property, the quotient power property, we could subtract 6 minus 4. We would simplify to 2 squared. For B, identifying the base of -7, in the numerator it has a power of 9, and in the denominator a power of 3. If we can subtract 9 minus 3 to simplify to -7 raised to the 6th power. For part C, h to the 7th power divided by h to the 6th power. Take the numerator exponent and subtract the exponent from the denominator, because all 6 of the h's in the denominator would cancel out, leaving 1, or just simply h. So let's give these a try. Simplify each expression. Write your answer as a power. So in A, since the base is 4, we could write 4 to the power 5 minus 2, which simplifies to 4 cubed. For part B, the base is the -2. The exponent would be 10 minus 3. So -2 to the 7th power. And finally C, the base is P, so P to the 7 minus 6, or P to the 1st power, which simply just gets written as the variable P. In example 2, you're being asked to simplify this expression and write your answer as a power. So the first thing we needed to identify is the numerator needs to be simplified using the product of powers property. So remember that when the base is the same, you can add exponents. So we'll want to do this first. So for the numerator, we would take 3 to the power of 4 plus 2. Simplify that to 3 to the 6th power. Now you're able to use the quotient of powers property. So 3 to the 6 minus 3 power leaves you with 3 cubed. Okay, please try this one and simplify writing your answer as a power. Notice that 5 to the 6th times 5 squared can be simplified using the product of powers property. So the numerator would be simplified 5 to the power 6 plus 2, which simplifies to 5 to the 8th power. Now we could use the quotient property. And our final answer would be 5 to the 4th power. And so we were asked to leave it as a power, and there's our answer. In example 3, you're asked to simplify a to the 10th over a to the 6th times a to the 7th over a to the 4th and write your answer as a power. So you could look at each one as really a fraction with a base that is the same. So a to the 10th over a to the 6th could be simplified as using the quotient of powers property, a to the 10 minus 6, times, in the second fraction you have a to the 7th over a to the 4th, so a to the 7 minus 4. A to the 4 times a cubed could then again be simplified using the product of powers property, and you could add the exponents. And get a to the 7th power. And if you're wondering, you could actually instead start by simplifying, since it's multiplication, a to the 10 plus 7 over a to the 6 plus 4, because the variables are all the same. This method that we're showing you in this example typically is when the bases are different in the two fractions, and we'll get to examples like that. So if you had a to the 17th over a to the 10th, you would then finally simplify as a to the 17 minus 10, which is still equal to a to the 7th power. So go ahead and give this a try. To simplify, we would want to take, in the first fraction, the bases are the same. So z to the 6 minus 2 times, again, we're still working with z, but now it's set up as another fraction, so z to the 8 minus 5 would give us z to the 4th times z cubed. And if we do the final step using the product of powers property, we get z to the 4 plus 3, which would be equal to z to the 7th. And then finally, I would like to go ahead and give you a couple other examples to use. Another example would be 3 to the 5th power times a to the 4th power all over to 3a squared. Now before we can simplify this, I'm looking at the denominator and I see a product power property where we need to apply the squared to the 3 and to the 2. So we could rewrite this to be 3 to the 5th times a to the 4th over, and remember that that is going to be 3 squared times a squared. Now, just as we solved the last one, we can't combine or add the exponents in the numerator or in the denominator because the bases are not the same. One is a 3 and one is an a. However, if we're looking at the top and the bottom number, we can see that this is really equivalent to 3/5 over 3 squared times a to the 4th over a squared. Therefore, we can simplify 3 to the 5 minus 2 times a to the 4 minus 2, which would be equal to 3 cubed times a squared, which could then be simplified to 27a squared. So when you have a number raised to a power and a variable raised to the power, a lot of times we actually evaluate the number part of it when we're simplifying. And one last example. If we're dealing with something a little more complicated, all right, we're just going to use a few more properties of math in order to simplify. So in this case, I want to simplify the expression. In the numerator, in order to simplify, I'm going to use the commutative property of multiplication. We know that this is 2 times w to the 6th power times 36 times w to the 8th power. So I'm going to rewrite it like that, because if I group together, the coefficients here, and I group together the variables, I see that they are both with the same base. We'll go ahead and write the denominator, but we won't do anything with it just yet. So I can actually evaluate the 2 times 36, which is 72, through multiplication. And then using the product property, 6 plus 8, I would have 72w with the exponent of 14 to the 4th. So you notice that there's going to be multiple steps of simplification. So this isn't something you can just, do a lot of mental math and get the answer. You're going to have to write down your steps. Now, I'm not done. In this case, because we have a number on the top and a number on the bottom, we're going to look for more ways to simplify. So we want to look for common factors between 72 and 18. And again, we could take the numeric part of it and say this is the same as 72 over 18 times w to the 14th power over w to the 4th. So I'm just rewriting the math, okay? Everything's the same. When you evaluate 72 divided by 18, or you try to simplify, they obviously both have a factor of 18, so it simplifies to 4. So 4, w to the 14th minus 4 power, is completely simplified when written 4w to the 10th power. And I know that was a lot of steps, and be prepared just to work through the steps and do each step simplifying using these properties as you see they're applicable.